Look at your hand. Now imagine stripping away the skin, the air, the floor, the entire planet underneath you, until all that's left is the galaxy you are quietly spinning inside. Here is the part nobody mentions. 85% of everything holding that galaxy together is completely invisible. No glow, no reflection, nothing any camera has ever caught. If that invisible scaffolding blinked off for a single second, the Milky Way would tear itself apart, and your sun, your planet, and your body would be flung out into the freezing dark like loose change off a table. We are told the universe simply stumbled into this perfect arrangement by pure luck. Randomness, apparently, walked into the ultimate engineering exam and aced it without studying. But the closer you look, the worse that explanation gets. We are riding inside a machine where most of the engine is hidden behind the dashboard, and we are supposed to believe nobody ever checked the numbers. Convenient, isn't it? To see the problem, start with a playground merry-go-round. Put one kid near the middle and one kid right at the edge, then spin it. The kid on the outside has to grip harder because the edge is always trying to throw them off. Spin it faster, and they have to hold on tighter still. A galaxy should obey the exact same rule. Stars near the bright, crowded center can race around quickly because there is a lot of mass packed inside their orbit pulling them in. Stars way out at the faint edge should crawl because there is almost nothing out there to hold them. That is just honest physics. It is how our own solar system behaves. Mercury, close to the Sun, sprints at 47 kilometers a second, while Neptune, far out at the rim, barely manages 5. In the 1970s, the astronomer Vera Rubin and her colleague Kent Ford measured the speeds of stars across dozens of galaxies, from the packed core all the way out to the faint outer rim. They expected a curve, fast in the middle, slowing toward the edge, exactly like the planets. What they found instead was a flat line. The outer stars were moving just as fast as the inner ones, sometimes faster. Picture a record player, where the needle at the very edge spins as if it were glued to the center. That is a machine lying to your face. At those speeds, with only the visible stars and gas to hold them, those outer stars should have been thrown off into empty space billions of years ago. The galaxy should be leaking stars like sparks off a grinder. It isn't. So physicists made the only diagnosis that fit the evidence. There must be far more mass than we can see, wrapped around every galaxy in a giant invisible halo, like a glass dome around a snow globe. You cannot see the dome, but every single snowflake obeys it. And then we did the bravest thing in all of science. We gave the mystery a name, dark matter, and quietly called it solved. A name is not an answer, but it does look wonderful, printed in a textbook. Now here is where it stops being a curiosity and starts being genuinely uncomfortable. The first warning came back in 1933 when the Swiss astronomer Fritz Zwicky weighed a cluster of more than 1,000 galaxies and found they were moving so fast they should have flown apart long ago. There was nowhere near enough visible mass to hold them. He called the missing weight dark matter, and the scientific world politely ignored him for the next 40 years. Then Rubin's flat lines arrived. Every galaxy in the catalogue showed the same disease, and the mystery refused to leave. Because that invisible mass is not a little bonus. Measure the whole universe, and you find a strict recipe for every kilogram of ordinary matter, the stuff in stars, planets, oceans, and your bones. There are about 5 kilograms of dark matter, 5 to 1. The European Space Agency's Planck satellite mapped the entire observable universe and confirmed that ratio in 2015, then checked it again in 2018. Everything you have ever seen or touched is roughly 5% of what is actually out there, and that ratio is not casual, it is surgical. Think of it like baking bread. Too little yeast and you get a flat brick. Too much and it swells into a collapsing mess. The dough does not care how confident you are, the chemistry has opinions. The universe is the same. Too little dark matter, and the early galaxies never gather enough gravity to form. The gas just drifts apart into a cold, dead desert where no star ever ignites. Too much, and gravity wins far too early. Everything slams together and collapses into a demolition yard of black holes before a single stable planet can take shape. 5 to 1. Not 4.9. Not 5.2. The one value that lets galaxies hold, stars burn, and the kind of chemistry that can ask questions exist. That is not one lucky dial. That is a whole panel of dials, all pretending to be a coincidence. And in 2006, the universe showed its hand. Two galaxy clusters had smashed straight through each other at thousands of kilometers a second, an event we now call the bullet cluster. The hot, ordinary gas crashed and piled up in the middle, like two ocean waves meeting head-on. But when astronomers mapped where the actual mass had gone, by watching how it bent the light of galaxies far behind it, the weight was not with the wreckage. It had sailed straight through, untouched, and come out the other side. A crime scene with the body in one room and the fingerprints in another. So the question gets uglier. It is no longer just what is dark matter. It is this. Why did the invisible part show up in exactly the right amount, at exactly the right moment, to build everything we can see? Now flip the question around. Forget what it is for a second. Ask what we could do with it. Dark matter has a property every engineer on Earth would kill for. It shapes the entire cosmos using gravity alone. It burns no fuel. It gives off no heat. It has held hundreds of billions of stars in formation for nearly 14 billion years, without a single repair, a single adjustment, or a single watt of power. Now compare that to us. We are trying to build fusion reactors, tiny artificial stars in a box, and we have spent decades and tens of billions of dollars just to hold a pocket of hot gas stable for a few seconds before the magnetic fields buckle and the whole thing collapses. Dark matter cradles entire stellar nurseries for billions of years and never once drops the load. In computing, our greatest enemy is heat. Every switch in a chip leaks thermal noise, which is why companies like IBM and Google chill their quantum processors to near absolute zero just to keep them thinking straight. Dark matter has produced exactly zero waste heat across the entire history of the universe, so we go hunting for it. CERN's Large Hadron Collider, 17 miles of superconducting magnets buried under the French-Swiss border, smashes particles together at staggering energies, watching for anything invisible to slip out. Result so far, nothing. A mile underground, inside a former South Dakota gold mine, the LUX-ZEPLIN detector sits perfectly shielded from the world, waiting for one dark matter particle to nudge a single atom and flash. It began its biggest run in 2022. Result, silence. Not poetic silence, detector silence. The kind with polished metal, international teams, and a carefully worded paper explaining that once again, nothing showed up. We built underground cathedrals of liquid xenon to catch one invisible visitor. The universe uses the very same stuff to hold 2 trillion galaxies together, and apparently forgot to leave us the receipt. A 1,000-galaxy cluster solved this problem in 1933 just by sitting there. We have thrown the most advanced machines in human history at it, and it still will not tell us its name. So strip it all down and look at what is left. 85% of all matter is invisible. It bends light without ever touching it. It holds every galaxy together without bumping into a single atom inside them. Its ratio to ordinary matter sits at precisely the value that lets stars form, planets cool, and creatures with eyes and questions exist. Move that number far in either direction, and the universe ends the same way, dark, silent, and empty. Zwicky saw it in 1933. Rubin confirmed it in the 1970s. The bullet cluster revealed its shape in 2006. Planck weighed it twice, and after nearly a century of looking, our finest minds still cannot tell you what it is made of. Only that without it, none of this is here. We are asked to believe that this hidden scaffolding simply happened to carry the right amount, the right behavior, the right timing, and the right invisibility to make galaxies, stars, planets, and us. That is a lot of luck doing a very specific job. The whole universe behaves like a machine that was checked twice before the first second of time even began. Which leaves only one honest question, the one the textbook is not allowed to print. Who calibrated this, if no one calibrated it?